Chapter 11, Part 1, and we're going to start on the nervous system. So a few study suggestions, really important. Remember that the PowerPoint is just an outline. Be sure to reference the text on topics that I cover in the PowerPoint. There's more in-depth information that you'll find in the text. Pay closer attention in the PowerPoint to the bolded, different colors, underlined, highlighted, and so on in the PowerPoint. Don't ignore the other stuff. Just pay closer attention to what I kind of make stand out. Watch all the screencasts and listen to my tips and hints. Complete the review worksheets for each chapter and unit, and then use those to prepare for the quiz and the test. Take notes on what you get wrong in the Smart Books. And if you can, attend the Zooms. And if the times that I have posted don't work for you, definitely reach out and we can find a different time that works for your schedule, and make sure that you bring questions to those Zooms. All right, so introduction to the nervous system. So we're going to start with the cells, and there's two main types of cells associated with the nervous tissue: neurons and glial cells. So we talked about neurons in the tissues early on in the semester. It probably seems like forever ago. But you may have remembered me saying that neurons tend to get all the credit, all the glory, and you don't really hear a whole lot about glial cells. Glial cells are the cells that support neurons and basically help neurons do their job, just like a doctor and support staff in the hospital, whether it be nurses or radiology or the physical therapy, occupational therapy, respiratory therapy, the medical lab. All of those areas help to support the doctors to do their job, to treat the patient, to cure the patient. Same thing goes for neurons and glial cells. Neurons are like the doctors and glial cells are the support. So a nerve is a bundle of axons outside of the brain and spinal cord. So when we start to kind of hash out what some of these things are, it's important that you know how to describe or define these things. So definitely start with, if it looks like it would be a term, be able to define or describe that term. And the first one that you're going to come across is the nerves. So again, a nerve is basically a bundle of axons outside of the brain and spinal cord. And we have cranial nerves, and they come from the brain. There are 12 pairs. And we also have spinal nerves. Those come from, or originate from, the spinal cord. And there's 31 pairs. So that means we have 24 total cranial nerves, and we have 62 total spinal nerves. However, I usually reference pairs. So remember 12 and 31 pairs. When we say the term ganglion, that is a collection of neuron cell bodies outside of the brain and spinal cord. A plexus is an extensive network of axons, or nerves, if you will, but it's a network of axons and nerves, and sometimes a few neuron cell bodies. And plexuses are located outside of the CNS, outside of the central nervous system, and we'll talk about more of those later. And then, like I said, glial cells are supportive cells with many different functions. So overall, what is the function of the nervous system? Well, there's a few different things here. The nervous system, in conjunction with the endocrine system, helps to maintain homeostasis. The nervous system regulates and coordinates physiology. The nervous system receives sensory inputs and then monitors internal and external stimuli. As far as the nervous system, we talk about integrating information. So it takes information it receives and kind of makes an assessment on that. So it processes sensory input and initiates responses. And that comes from the brain and spinal cord. And I'll talk about this later, but I'll mention it now, that the brain is kind of the part of the nervous system that everybody thinks that all the response stimuli come from, but really in emergency situations or situations where you don't have time to think about what to do, your spinal cord steps in and does this fight or flight kind of response. So our spinal cord can make decisions to keep us alive, basically. And something as simple as, and again, we're going to talk about this later, but something as simple as if you leave a spoon in a you're cooking something on the stove and you put a metal spoon in there and you leave it in there for a while and you go to pick up that spoon and it's really, really hot, you don't think to yourself, oh, this is a hot spoon, I'm going to let go of it. No, you let go of it before you even have a chance to think about the hot spoon. And that's where your spinal cord kind of jumps in and, saves you from burning yourself, or hopefully saves you from burning yourself. So, in addition, functions of the nervous system helps to control muscles and glands. And then also the nervous system establishes and maintains mental activity, our consciousness, thinking, memory, emotion. All of that comes from the nervous system. All right, so we have divisions of the nervous system, sometimes referred to as subdivisions. We have the CNS and the PNS. So the central nervous system is the brain and spinal cord. No nerves, just the brain and spinal cord in the CNS, which makes sense because it's kind of the central location of all the important stuff in the nervous system, or most of the important stuff anyway. The peripheral nervous system is basically the nerves, anything outside of the brain and spinal cord, so sensory receptors and nerves. The peripheral nervous system, the PNS, is divided into a couple different divisions, the sensory division and the motor division. And think of this when we're going to talk about this again, but sensory division, where is sensory stuff happening? Okay, our sensory stuff is happening, it's based on our environment, or maybe we have, maybe we put a grape piece of bubble gum in our mouth and we taste it, and that's a sensory piece of information that is carried to our brain through receptors in our tongue, and our brain decides, yep, that's grape gum and I like that. If we go back to the burning spoon, okay, the spoon is really hot and you touch the spoon, it's hot, that information goes to the brain and says, yep, hot spoon, and the motor division, it receives information from either the brain or spinal cord in this case, to let go of the spoon. So that's the motor. So sensory is what you sense, what you take in, either by touch or sight or smell or taste. And motor division is the acting upon whatever you've taken in. So we'll go into that a little bit more. So this is just an illustration of how the PNS and CNS are divided. So you can see the brain and spinal cord, CNS, and then everything else, all your nerves, are in the PNS, central nervous system, peripheral nervous system. So information flow in the nervous system. So, sensory input happens. It is taken to the spinal cord and then up to the brain. So sensory division comes from the PNS, comes from receptors, and then through the nerves to the spinal cord and brain. And then motor division, basically, depending on what information was brought in, the brain will send information to the spinal cord, which will then either go out to the somatic nervous system, such as specifically the skeletal muscle, or the autonomic nervous systems, which are divided further into two different groups, sympathetic and parasympathetic. And the effectors here, or the end receiver of information, is the effector. And the end receiver of information in the autonomic nervous system, sympathetic, parasympathetic, include cardiac, smooth muscle, and glands. So sensory input comes in: light, sound, taste, smell, touch, temperature, pain, pressure, etc. comes in, and then motor output, movement, changes in metabolism, heart rate, breathing rate, etc. So again, we'll talk a little bit more about this. So I'm going to stop here and pick up on part 2 and going into the divisions of the PNS.